Hello and welcome to another video. In this video I'll be going through mock set for paper 3 of the EDEXCEL higher tier. Let's get straight into it. Question 1 says write down the inequality shown in the diagram. So here we have a number line with an empty circle. An empty circle means less than. You can have two types of inequalities, less than or less than and equals to. And the line stops here, but really what that's indicating is it keeps going into infinity. So this is just going to be x less than 2. And that was question 1 for 2 marks. Question 2 says the nth term of the sequence is n squared plus 5. Find the first two terms of this sequence. So if we put 1 into this, we'll get 1 plus 5, which is 6. And then if we put 2 in, that'll be 4 plus 5, which is 9. Part 2 says, is 126 a term in this sequence? You must show how you get your answer. So what we could do is we could let this nth term equal 126 and see if we come up with a whole number. So n squared plus 5 equals 126, and then solve this. So take 5 from the right hand side, n squared would equal 121, and you know that the square root of 121 is 11, and we get a whole number. That means the 11th term is 126, so we can say yes, 126 is a term in the sequence and it's the 11th term. So we could say the 11th term equals 126. For 1 mark. Part B says here's the first 5 terms of an arithmetic sequence, 26, 19, 12, 5, minus 2. Find an expression in terms of n for the nth term of this sequence. So one way to do this is just find the difference between each term. So 26 to 19, we've taken away 7, and 19 to 12, we do the same thing. So you can see the common difference is -7. So we're multiplying n by -7, and then you have to figure out if I substitute 1 into this, -7 times 1, what do I need to add on to get to 26? So -7 plus 33 will get you to 26. So this is going to be -7n plus 33. And then check that it works. So if I put 2 into this, I get -14 plus 33. That will get me to 19. And then maybe do another one. If you're still not sure, so substitute 3 minus 21 plus 33, that will get you to 12. So you can be pretty confident that's correct. For 2 marks, that was question 2 for 4 marks. Question 3 says the table gives information about the times that 100 people took to travel to work. Find the class interval that contains the median. So the median is the middle value. One way you can find that is to do n plus 1 divided by 2. Where n is the total frequency. So we're told this table contains information about 100 people. So this is going to be 101 on 2 or 50.5. So go down the table and find the 50th and the 51st terms. So adding these up, that'll be 36. And then if I add 23 to that, that's going to be 59. So you can see that the median's going to be in this one here, 20 to 30. So that's all we need to write down for that one. T between 20 and 30. Part B says draw a frequency polygon for the information in the table. So the key with drawing frequency polygons is you need to use the midpoints of these class intervals here. So between 0 and 10, you're going to plot that at 5 and 10 on the y-axis. So the frequency is the y-axis, and 5 on the x-axis, so this is going to be 5, 10. The next one will be at 15, 26. So that's going to be there. The next one's at 25, 23. The next one is 35, 19. The next one, 45, 14. And the last one, 55, 8. Okay, then you just need to go ahead and join those up with straight lines using your ruler, and then you're done. And it doesn't really matter if you join them up to the x-axis. All they really care about is that you're getting that part correct. So you can join them up or not, you'll still get the mark. So that was part B for 2 marks and question 3 for 3 marks. Question 4 says in London 1 pint of milk costs 58p, in Paris 1 litre of milk costs 1.05 euros. 1 litre equals 1.75 pints, 1 pound equals 1.17 euros. In which city is the milk better value for money? London or Paris? You must show you're working. So here there's a number of ways to do this. You could find, change this cost into 1 pint per pound, or the other one into 1 litre per euros, and that's what I'm going to do. I'm going to change the London price into litres per euros. So if we talk about London, we want to change this ratio to 1 litre per however many euros it's going to cost. So to find 1 pint in litres, we need to kind of reverse this. So this is going to be 1 divided by 1.76 for 1 litre. And then to change pounds to euros, we need to multiply that by 1.17. So that's going to be 0.58 times 1.17. And then we just need to solve this. So this is going to be 1 over 1.76 multiplied by 0.58 times 1.17. If we put that into a calculator, I'll just do the bottom line. So 1.76 multiplied by 0.58 multiplied by 1.17. We get 1.19 approximately. I'll round that off to 1.19. So that's 1 litre per 1.19 euros. And you can see the cost in Paris is 1 litre costs 1.05 euros, so it's actually cheaper in Paris. So therefore, it's cheaper in Paris. I should probably summarize this information. So in Paris, 1 litre equals 1.05 euros, and in London, 1 litre equals 1.19 euros. As I said before, you could have done it the other way. However you want to do that, as long as you're getting the prices with the same units, then you can compare them. Okay, that was question 4 for 3 marks. Question 5 says Simon can see 2 lights, light A and light B. Light A flashes every 15 seconds, light B flashes every 18 seconds. At 10 p.m. both lights flash at the same time. How many more times will both lights flash at the same time in the next 4 minutes? Okay, so if they're flashing at 15 seconds and 18 seconds, to find when they flash at the same time, we need the lowest common multiple of both of those numbers. So one way to find the lowest common multiple is to find the prime factors of each number and then use those prime factors. So let me show you what I mean by that. So 15, prime factors of 15 are 3 and 5. Prime factors of 18, that's like 9 times 2, so that's going to be 3 times 3 times 2. And so the lowest common multiple of 15 and 18 is, well, we take these prime factors. If there are any factors common to both, we only count those once. So because I have a 3 in both, a 3 in 15 and a 3 in 18, I only count that once. So the lowest common multiple is going to be 2 times 3 times 3 times 5. So this is going to be 6 times 15, which is 90. And we're talking about seconds, so this is 90 seconds, or 1.5 minutes. So in 4 minutes, well, it would flash at 1.5 minutes, and then at 3 minutes, and then it wouldn't flash again in 4 minutes. So this is going to be twice for the answer to this question. Okay, that was question 5 for 3 marks. Question 6 says the diagram shows a concrete block on the horizontal ground. The block is cuboid, 12 by 12 by 65. The block exerts a force of 220 newtons on the ground. Calculate the pressure that the block exerts on the ground. Give your answer in newtons per centimeter squared. Okay, so they've given us the formula for pressure, and we need to calculate the area of the bottom of this cuboid. This here is kind of a red herring. It's maybe trying to trick you or something, wondering whether you need to calculate the volume or something, but we don't need that. We just need the area of the bottom of this cuboid and substitute it into this formula, and then we'll have the pressure. So the area is going to be 12 times 65. Let's just put that into a calculator. So 12 times 65, we get 780 centimeters squared, and then use this formula. So the pressure is going to be the force over the area, which is 220 over 780. Put that into a calculator. 220 divided by 780, and we get 0.282 approximately. 0.282 newtons per centimeter squared. And it doesn't say a degree of accuracy, so round off to whatever you like. I'm not sure if you can even give your answer as a fraction. I don't know, but I would just leave that as a decimal. And so my final answer is 0.282 there for 2 marks. Question 7 says the diagram shows triangle ABC. The perimeter of the triangle is 64 centimeters. The ratio of the sides is 6 to 5 to 5. Work out the area of the triangle. Okay, so AB is 6 parts and the other two are 5 parts. Well, that already tells you it's an isosceles triangle if these two sides are equal. We could also work out the lengths of those sides. So divide 64 by the number of parts in this ratio, which is 16. So 64 divided by 16, that's 4. So that means this side is going to be 6 times 4, which is 24 centimeters. This one's going to be 20 centimeters, and same for this one over here. And we need the area of the triangle. That means we need the height as well. So if this is an isosceles triangle, we could split this up into 2 right-angled triangles, and they will be congruent, which also means this base is split in half. So this is going to be 12 here. So that will allow us to find the height using Pythagoras' theorem. So we could say the height equals the square root of the hypotenuse squared, take the other leg squared, so 12 squared. If we put that into a calculator, we'll just do the whole thing. So square root of 20 squared, take 12 squared, and we get 16. So the height is 16, then we just need to do the height times the base divided by 2 to get the area. So the area is going to be 16 times 24, or 16 times 12. That's going to be 192 centimeters squared. So the final answer there, 192 for 5 marks. Fairly surprisingly, that's 5 marks. I guess you have to recognize how to find the height, so that can be pretty difficult. But that was question 7. Question 8 says complete the table of values for y equals x cubed, take 3x plus 1. Okay, so we just need to substitute these values for x into this. So minus 2 into this would be minus 8. Take plus 6, plus 1. That's going to be minus 1. Minus 1 into this would be minus 1 plus 3 plus 1. That would be 3. 0, we'd be left with plus 1. 1 into this, that would be 1 take 3 plus 1. That would be minus 1. Minus 2 plus 1, minus 1. And then 2 into this would be 8 take 6 plus 1. That's 2 plus 1, which is 3. Okay, so that's 2 marks to complete that table. Then we need to plot the points. So minus 2, minus 1 is down here. Minus 1, minus 3. Minus 1, 3 is up here. 0, 1 is here. 1, minus 1 down here. And 2, 3 is back up here. Okay, so we've got a nice cubic shape to this, and make sure that you try to sketch that curve in. Don't just join them up with straight lines. Going through all the points, so as neatly as you can, and then the final curve over here, and then down to the point down here. And you don't need to go past those points because it says draw the graph between minus 2 and 2. Okay, so that was part B, and question 8 for 4 marks. Question 9 says find the value of 6.6 times 10 to the minus 11 times 7.35 times 10 to the 22, all divided by 1.74 times 10 to the 6, all squared. Give your answer correct to 1 decimal place. So what I would do is just put that straight into a calculator as it is. You could simplify it if you liked, but I'm not sure whether that would help or not. And you should have a standard form button to make this slightly easier. So we've got all of this on the top line, and then 7.35 times 10 to the 22, all of that divided by 1.74 times 10 to the 6, all squared. Press equals, and you should get 1.619, etc. And it says to 1 decimal place, so to 1 decimal place this is going to be 1.6. Now, depending on the calculator you've got, a fraction button would make this a bit easier. You're not going to have this type of calculator. Hopefully you have one of those newer scientific calculators with a fraction button. That will make this easier to put in and make sure you don't get any mistakes when you're putting it in. Okay, that was question 9 for 2 marks. Question 10 says the cumulative frequency graph gives information about the number of minutes each of 60 people was in a shop. Okay, and part A says find an estimate for the number of people who were in the shop for more than 40 minutes. Alright, so you need to know how to read a cumulative frequency graph. If you want more than 40, you need to find 40 on the x-axis and go up to the graph and then go across to the cumulative frequency. And what this tells you is that about 53 people spent less than 40 minutes in the shop. That means we had about 7 people spending 40 or more minutes in the shop. Okay, so the answer there is 7. Part B says Stan has to use the graph to find an estimate for the lower quartile of the times. Stan writes 60 people were in the shop. 25% of 60 is 15, so the lower quartile of the time is 15 minutes. What mistake has Stan made? So he needs to use the graph to find the lower quartile. So he needs to use this 15, which is not the time, it's the frequency. So he needs to go to 15 on the cumulative frequency, go across to the graph, and then down to the time. So he'd actually get about 18.5 or so, something like that. So the main mistake he has made is that he hasn't used the graph correctly. So he needs to use a graph. So he needs to use a graph to find Q1, which would be about 18.5 minutes. So that's for 1 mark. And question 10 for a total of 3 marks. Question 11 says here are 2 rectangles, A and B. The length of rectangle B is 25% greater than the length of rectangle A. Okay, so if we wanted to increase something by 25%, we would multiply it by 1.25. The width of rectangle B is 3/5 times the width of rectangle A. Find the fraction area of the rectangle B over the area of rectangle A. Give your answer in its simplest form. Okay, so then the width is going to be 3/5 times A. So let's say the width of A would be W and the length of A would be L. So the area of A would be just WL, W times L. Then the area of B would be, another way of writing 1.25 is 5/4A. So this is going to be 5/4 times the length of A, which we've called L. So I should just change these. This would be L and W. Okay, so this is going to be L times 3/5 W. And then simplify this a little bit. So if I'm multiplying these together, I could actually cancel out these 5s. So this would just be 3/4 W times L. And then if we wrote this as a fraction, the area of rectangle B over the area of A, this would be 3/4 WL over WL. Well, then those width times length cancel out, so we're just left with 3/4 for our final answer. Okay, that was question 11 for 3 marks. Question 12 says, in a class there are 11 boys and 19 girls. The mean weight of all 30 children is 32.85. The mean weight of 11 boys is 31.9 kilograms. Work out the mean weight of the 19 girls. Using this information here, the 11 boys has a mean weight of 31.9. We can find the total weight of the boys, and then that will allow us to work backwards and find the weight of the girls and then the mean weight. So we could say 31.9, that mean equals the sum of the weight of the boys. So that just means sum of the weight of the boys divided by the number of boys, which is 11. So this is going to be 31.9 times 11. Put that into a calculator, 31.9 times 11, 350.9. So then the total mean, which is 32.85, will equal the sum of the weight of the girls plus 350.9 divided by the total number of people in the class. So 11, so that's going to be 30. Well, they told us that. Then we can solve this equation for the weight of the girls and then divide that by 19 and we'll have the mean. So multiply this by 30. So let me just write this down. So the sum of the weight of the girls is going to be 32.85 multiplied by 30 and then subtract 350.9. Okay, put that into a calculator. So 32.85 times 30, take 350.9. That gives us 634.6. And then the mean of the girls is going to be that weight divided by 19. Okay, put that into a calculator. The answer divided by 19, which is 33.4. Okay, 33.4 kilograms for final answer. That was question 12 for 3 marks. There might be a slightly different way to do that, but that would be the general process. Question 13 says, when Lee goes to work, he either travels by car or by bus. The probability that on any day Lee goes to work, he travels by car is 0.2. When Lee travels to work by car, the probability that he's late is 0.35. When Lee travels to work by bus, the probability that he's late is 0.15. Complete the probability tree diagram for this information. Okay, by car, 0.2. That means by bus is 0.8. All of these trees must add up to 1. So when it's by car, the probability of being late is 0.35. That means the probability of not being late is 0.65. By bus, being late is 0.15. So not late will be 0.85. Okay, part B says work out the probability that on any day Lee goes to work, he is late. Okay, so the branches of this tree we want is by car and being late or by bus and being late. So the probability of being by car and being late is going to be 0.2 times 0.35. And the probability of being by bus and being late will be 0.8 times 0.15. Now, if you're confused about whether to multiply or add, remember that when you're talking about probability, when you say the sentence and you say and, you multiply, and when you say or, you add. So he's going by a car and he will be late, so we multiply. He's going by bus and he will be late, we multiply. And then to add these probabilities together, we say he either goes by car and he's late or he's by bus and he's late. So we need to add these together. So the sum here is going to be 0.2 times 0.35 plus 0.8 times 0.15. And we just need to put that into a calculator. 0.2 times 0.35 plus 0.8 times 0.15. And we get 0.19. So overall there's a 19% chance of being late. That was for 3 marks, and question 13 for a total of 5 marks. Question 14 starts off with the formula and it says the value of R is decreased by 20%. The value of G and the value of M are not changed. Calculate the percentage increase in the value of G. If we were to decrease R by 20%, that's the same as multiplying by 0.8. So let me just write this out again. And if we were to substitute in 0.8 R for R here, we need to square all of that. So it's R decreased by 20% and then squared. So this would be GM over 0.8 times 0.8 is 0.64. And then we'd have that R squared. So another way of writing this is GM over R squared multiplied by 1 over 0.64. And so because G is directly proportional to this here, GM over R squared, whatever we do to this side of the equation, the right hand side, we need to also do to the left hand side. So if we're multiplying this by 1 over 0.64, well, we could put that into a calculator. So 1 over 0.64, that's 1.5625. So that means we also need to multiply G by 1.5625. So let me just write that out. So 1 over 0.64 equals 1.5625. If you multiply something by this, that's the same as increasing by 56.25%, right? So if you multiply something by 1.5, that's an increase of 50%. So this is going to be an increase of 56.25%. And that was question 14 for 3 marks. Question 15 says, here is a trapezium ABCD. AB and DC are parallel. Work out the area of triangle BCD. Give your answer correct to 3 significant figures. Right, so we have these lengths here. We need to work out the area of BCD, which is this triangle in here. So we've got the base, all we need is the height. So wherever we find the height of this trapezium, that will allow us to find the area of this triangle. So we have some angles in here. I'm thinking this is going to allow us to find the height of this triangle. So the first thing I'm going to do is to find this angle in here, this missing angle. So if these add up to 144, this means that this angle will be 36 degrees because they all need to add up to 180. Then what I might do is to find this dB, this length here, using the sine ratios. So the sine ratios say that A over sine A equals B over sine B. So if I use this for side A, 39, this would be angle A, and then this is going to be angle B, and this would be side B. So I can say that 39 over the sine of 74 equals B over the sine of 70. What this allows you to do is to solve for that unknown side. So B is going to equal the sine of 70 multiplied by 39 on sine of 74. Okay, so let's put that into a calculator. The sine of 70 multiplied by 39 divided by the sine of 74. And we get 38.125 approximately. So 38.125. So that's that hypotenuse. Well, not really a hypotenuse, but just this unknown side. So 38.125. And now I have this length, I can turn it into a hypotenuse. That was what I was going to go to next, by creating a right angle triangle here, which has this angle 36 degrees. And what I'm looking for is this height. And in order to find that height, I could use the sine ratio. So the sine of 36 equals the opposite side over the hypotenuse. The opposite side in this right angle triangle is the height. So that's going to allow me to solve for this height. So I can say the sine of 36 equals the opposite side over the hypotenuse, which is going to be h over 38.125. So therefore, the height equals the sine of 36 multiplied by 38.125. So just put that into a calculator, take that answer that you previously had, multiply it by sine of 36, and we get 22.409 approximately. So 22.409. Okay, now I have the height. I can find the area of this triangle by just multiplying the base times the height and then dividing by 2. So the area of triangle BCD is going to be 52 multiplied by 22.409 divided by 2. Okay, so 52 multiplied by the previous answer divided by 2 gives us an answer of 582.64. 582.64. Does it say to round off? 3 significant figures. So to 3 significant figures, that's going to be 583 because that needs to be rounded up. Okay, that was question 15 for 5 marks. Question 16 says shape A and shape B are 2 similar solid shapes. The ratio of the volume of shape A to the volume of shape B is 1 to 10. Aisha says that the height of shape B is 10 times the height of shape A. Is Aisha correct? Give a reason for your answer. Okay, so the ratio of the volumes can be written as the cube of the ratio of the heights. So if we had the heights of A and B, we could cube these to get the ratio of the volumes. So if they give us this ratio, which they've said is 1 to 10, then this would be the ratio of the heights cubed. So that means the ratio of the heights would be the cube root of this. So this would actually be the cubed root of 1 on the cube root of 10, in other words. Okay, so Asia is not correct. No, the ratio is actually 1 to the cube root of 10. Okay, that was part A for 1 mark. Part B says the surface area of shape B is 72 centimeters squared. Work out the surface area of shape A. Give your answer correct to 3 significant figures. Okay, so again, we need to use ratios for this. So we're looking for the surface area of A. The surface area of B is 72. And the ratio of the surface areas in relation to the height is similar to the volume, but this is the ratio of the heights squared, not cubed. Okay, so if we were to, now we know the ratio of the heights is 1 over the cube root of 10. So if we were to square that, another way of writing that is 1 over the cube root of 100. So squaring a cube root, you can also just square the number inside the cube root, and you'll have the same thing. And 1 squared is just 1. So we can say this ratio is equivalent to 1 over the cube root of 100. All right, and then we can solve for the surface area of A. So the surface area of A is going to equal 72 over the cube root of 100. So there I have just multiplied 72 over here, so 72 times 1. And if we put that into a calculator, 72 divided by the cube root of 100, 100 equals 15.5119, and it says to 3 significant figures, so to 3 significant figures this will be 15.5. Okay, for a final answer, that was 2 marks, and question 16 for a total of 3 marks. Question 17 says Kelly grows potatoes. She has 2,500 kilograms of potatoes, correct to the nearest 10 kilograms. Kelly's going to put the potatoes into sacks. Each sack will contain 12.5 kilograms of potatoes. Kelly assumes that 12.5 kilograms is measured correct to the nearest 0.1 kilograms. Does Kelly definitely have enough potatoes to fill 200 sacks? You must show how you get to your answer. Okay, so let's find the upper and lower bounds of the potatoes. So the lower bound, if we're rounding to the nearest 10 kilograms, 2,495 would round up to 2,500. So we're talking about potatoes here. And 2,505, anything below that would round down to 2,500 to the nearest 10. So that's just less than, not less than or equals to. Okay, so that's the upper and lower bounds of potatoes. For the sacks, they're rounded to the nearest 0.1 kilograms. So for the sacks, if we were to round 12.5, so 12.45 would round up to 12.5 to the nearest 1 kilogram. And 12.55 would round down, anything below that. Okay, so we have the upper and lower bounds of the potatoes in the sacks. What's the minimum that the potatoes could weigh? Well, that's this 2,494. So the potatoes, the minimum value of the potatoes could be 2,495 kilograms. And what's the maximum that the sacks could weigh? That would be 12.55 kilograms times 200. So the sacks max would be 12.55 times 200. Put that into a calculator. 12.55 times 200, 2,510. So the minimum that the potatoes could be is less than the maximum that the sack weights could be. So she definitely could have not enough potatoes, So the question, does Kelly definitely have enough potatoes? No, she might not have enough. No, because the minimum weight of the potatoes is less than the maximum weight of the sacks. So 200 sacks can weigh 2,510 kilos, and Kelly might only have 2,495 kilograms of potatoes. That was for 3 marks. Okay, part B says Kelly's assumption is wrong. 12.5 kilograms is measured correct to the nearest 0.5 kilograms. Explain how this could affect your decision in part A. So if 12.5 kilograms was measured to the nearest 0.5 kilograms, we need to change our upper and lower bounds. So what would round to 12.5 to the nearest 0.5? So 12.25. If I was rounding that to the nearest 0.5, that would round up to 12.5. So it would be greater than or equals to that. And it's going to be less than 12.75. Anything less than that rounds down to 12.5. Okay, now the maximum weight of the sacks has actually increased. So this number here would actually get higher. So no, that would not affect the decision in part A because the upper bound has actually increased. Okay, so let me just write that out. So the max weight of sacks increases, so therefore no change in decision for 1 mark. That was question 17 for 4 marks. Question 18 says write 3 times x take 1 over x squared take 4x take 5. Subtract 2 over x take 5 as a single fraction in its simplest form. Right, okay, so the first thing I want to do here is to factorize this denominator because if I want to combine these two fractions, I need a common denominator. So I need to know what to multiply this x minus 5 by. So let me start off by trying to factorize that quadratic there into 2 brackets. And this is going to take 2 over x take 5. Okay, so I need multiples of 5 that make 4. Well, the only multiples of 5 are 5 and 1. So let me write those in, and they need to make -4. So this is going to be a -5 and a +1. If I expand those out, I'll have x squared take 4x take 5. Okay, now I have this x take 5. I need to multiply this fraction by x plus 1 in order to combine them. So on my next line, I'll have 3 times x 1, that numerator stays the same, take 2 multiplied by x plus 1 all over x take 5, x plus 1. Now I can go ahead and simplify the numerator. So expand those brackets out, 3x take 3, subtract 2x take 2, so that's -2 times plus 1, all over x take 5, x plus 1. Then 3x take 2x, that's just x, minus 3 take 2, that's minus 5, all over x minus 5, x plus 1. Then I have an x plus 5 on the top line and an x plus 5, sorry, an x subtract 5 on the top and the bottom line. They cancel out. So I'm just left with 1 as the numerator and x plus 1 as the denominator for my final answer there. So 1 over x plus 1. That was question 18 for 4 marks. Question 19 says the diagram shows a solid made by joining a solid hemisphere to a solid circular cone. The center of the plane face of the cone coincides with the center of the plane face of the hemisphere. The radius of the hemisphere is 3 centimeters. The radius of the base of the cone is 3 centimeters. The volume of the solid is 30 pi centimeters cubed. Work out the total surface area of the solid. Give your answer as a multiple of pi. Right, so they give us the total volume. We want the surface area, and they give us the formulas for the surface area and the volume of a sphere and a cone. And you can see to work out the surface area of the cone, we're going to need the height and the slant length, or the length of the side. Okay, so this is going to involve working backwards in order to go forwards. You can see here that we can work out the volume of the semisphere because all we need for that is the radius. So we do the volume of the sphere divided by 2. That will allow us to find the volume of the cone by taking that away from the total volume. Then working backwards, using the volume of the cone, we'll be able to find the height, which will then allow us to find the length of the side. So let's go ahead and show some of this working out. So the volume of the semisphere is going to be 4 on 3 pi r cubed divided by 2. Another way of writing that is just 2 on 3 pi r cubed. So that's the volume of half of a sphere. Substituting the radius for that, 2 on 3 pi 3 cubed is 27. But then we can straight away divide it by 3 again. So 27 divided by 3 is 9. 9 times 2 is 18. So my final answer for the semisphere volume will be 18 pi. Therefore, the volume of the cone is going to be 30 pi. Take away the volume of the semisphere. So 30 take 18 will be 12 pi. I should have the pi's in there. Okay, so hopefully you can see what I did there. Then I can use that answer with this formula, volume of the cone equals a third pi r squared h, to get h. So therefore 12 pi equals a third pi 3 squared, 3 being the radius, times h. So therefore h equals, well, one of these 3's would cancel out with this 3 down here. So this would just be 3 pi. Then divide the left-hand side by 3 pi, so we'd have 12 pi divided by 3 pi. 12 pi divided by 3 pi, well, the pi's would cancel out, so we're just left with 12 divided by 3, which would be 4 centimeters. Now back up to the diagram, we also needed this length here, this L, the slant length. We have the height of the cone, which is 4. So this is like a right-angled triangle. We can use Pythagoras to work out the hypotenuse of that triangle. And if you've seen this right-angled triangle before, with 3 and 4 being the legs, then you know the hypotenuse is 5. You can also just work that out, but that's a pretty common right-angled triangle, 3, 4, 5. So we could say, therefore, L equals 5 centimeters. Now we have all the variables we need to work out the surface area of the cone. We have the radius and the slant length. And we also have what we need to work out the surface area of the semisphere, which will just be the surface area of the sphere divided by 2. Okay, so let's go ahead and use these formulas to work out the total surface area. Okay, so the surface area of the cone equals pi RL, which is pi times 3 times 5, which is 15 pi centimeters squared. The surface area of the semisphere is 2 pi r squared. Remember, we just took 4 pi r squared and divided by 2. Substituting the radius into that. So that'll be 2 pi times 9, which is 18 pi centimeters squared. 18 plus 15, that will be 33 pi centimeters squared. Now you can leave your answer as that. I wouldn't bother multiplying that out and having a decimal answer, although I don't think that would be wrong, but you can leave it as 33 pi. That's perfectly fine. And that was question 19 for 5 marks. Question 20 says solve algebraically the simultaneous equations y equals 2x squared take 3x take 10 and 2x take y equals minus 2. Alright, so if we call this 1 and 2, what I might do is to rearrange equation 2 so that y is the subject, and then substitute that into equation 1. You could do it the other way around. You could make x the subject and then substitute it in, and that wouldn't be wrong either. Okay, so 2 I could rearrange so that if I added y and then added 2 to the left hand side, this would be y equals 2x plus 2. And then substitute that into equation 1. Then we can write that as 2x plus 2 equals 2x squared take 3x take 10. So I hope you can see I've just taken this part here and substituted it in for the y there. Okay, then simplify this. So what we want is the quadratic equaling to 0, because that will allow us to solve for x. So take the 2x from this side, take the 2. So this is going to be 2x squared take 5x take 12 equals 0. And now we can try to factorize this and then solve for x. So what are some factors of 12? And one of them multiplied by 2, which would make minus 5. The only factors of 2 are 1 and 2. And the factors of 12, well, we could try 4 and 3. So 2 times 4, that would be 8. Take 3 would be 5, but we need it to be a minus 5. So if this is a minus 4 and a plus 3, then this would be minus 8 plus 3 would make minus 5. So we can factorize this. Our first terms will be 2x and x. We need to multiply that 2x by a minus 4 and the x by a plus 3, and that would expand out to our quadratic there. So therefore, we have 2x plus 3 equal to 0, or x minus 4 equal to 0. Remember, when you're trying to solve a quadratic, you set the brackets equal to 0 because anything multiplied by 0 equals 0. So this is your next step here. Then we can solve these for x. So either x equals minus 3 on 2 or x equals 4. Okay, so we're going to have two solutions. We need to substitute these into one of our original equations to find the y value. So if we take equation 2, so sub into 2, minus 3 on 2. Let's do x equals minus 3 on 2 first. So this would be 2 multiplied by minus 3 on 2, take y equals minus 2. So I'm just using this equation here and substituting in for x there. So if I keep solving this, this would just be minus 3, take y equals minus 2, plus that minus 3 to the other side. This will be minus y equals 1, so therefore y equals minus 1. Now let's do x equal to 4, so 2 times 4 take y equals minus 2, so therefore minus y equals minus 2 take 8 would be minus 10, so therefore y equals 10 if I divide by negative 1. So my solutions there become minus 3 on 2, minus 1, and 4, 10. And that was question 20 for 5 marks. Question 21 gives us an axis, and it says that the shaded shape is rotated 180 degrees about the point 2, 2. How many of the vertices of the shaded shape are invariant? Okay, so 2, 2 is here. If I rotated that 180, it would be basically flipped around, or, turned 180 degrees, so it would be there. Invariant just means it hasn't moved at all, or it's in the same place where it started. I can only see one point that would stay the same, which is this center point here. So my answer, how many vertices, would be 1 for 1 mark. Part B gives us another axis, and it says rectangle ABCD is transformed by a combination of two transformations so that all points on AB are invariant and there are no other invariant points. The first transformation is a reflection in the line with equation y equals k, where k is an integer and k does not equal 1. Describe fully the second transformation. Okay, so let's try a few things here. Let's say y equaled 2. Alright, so that would be the line y equals 2. If we reflected this shape in that line, it would end up here. And AB would be up here. So this would be AB. And then we need to do another transformation for it to get back to the same place it started. So we could, if the line was at y equals 2, we could translate that down negative 2, and AB would be here, and then, well, the whole rectangle would be here, but AB would be back in the same place. It doesn't say k equals 2. That's just one possibility. Let's try another one. So let's say y equaled 3. So if the line was here, and we reflected this shape in that line, it would end up here, and AB would be up here. Then we would have to translate it 1, 2, 3, 4 down in order for AB to be back in the same place. So if y equals 2, the translation is 0 minus 2. If y equals 3, the translation is 0 minus 4. Let's try the other way. Let's say if we had a negative number. Let's say we had k equal to 0. So the line is there. And we reflected this shape in this line. So AB would be here. In order for it to get back to where it started, we'd have to translate it up to. So if y equal to 0, the translation would be 0, 2. So what I'm looking for is some kind of pattern in order to describe this translation in relation to k. So let's say if I wrote these out as kind of like a sequence. Now we don't have 1, which is kind of tricky, but 0 is 2, 2 is minus 2, and 3 is minus 4. So you can imagine 1 would actually be 0, wouldn't it? So we could represent this kind of like a sequence, and it's going down by 2, right? The difference between these terms is negative 2. So 2 to 0 is negative 2, 0 to minus 2, negative 2. So if we wanted to represent that sequence, it would be negative 2k, whatever k is. The first term is 0, so we'd have to add 2 to it. Okay, so this is a pretty tricky kind of question, I think. And for sure there are other ways to think about this, but my translation is actually going to be negative 2k plus 2, or if you were to write that around the other way, 2 take 2k. So we need a translation in relation to k because we're not told what k actually equals. All right, so my final translation there is going to be 0 for the horizontal translation and 2 take 2k for the vertical translation. A fairly difficult 2-mark question there, but that was for a total of 3 marks. Question 22 says, here's a sketch of a graph of a trigonometric function for 0 to 360. Write down a possible equation of the graph. Okay, so I know it's not the sine graph, or it could be if it's been shifted. The cosine graph starts at 1 and goes down to 90, because remember the cosine of 0 equals 1. So the cosine graph starts at 1, goes down and then up like that. So it could be the reverse of the cosine graph, so negative cosine x, or the cosine of x plus 180, so it's been shifted 180 degrees. I'm just going to write negative cosine of x, but there are multiple answers to that question. It could also be a sine graph shifted 90 degrees. Okay, so it doesn't have to be a cosine graph. Part B says, here's a sketch of a graph of y equals cosine of x take p plus r for x between 0 and 360. Find the value of p and the value of r. Okay, so the general form of a trigonometric function is a cosine of bx take c plus d, and all of these different variables have an effect on the graph. The only ones we care about are these two here. So d is the vertical shift, and c is the phase shift, or the horizontal movement. So the vertical shift is probably the easiest one. If you think of a cosine graph and it starts at 1, goes down to 90, down to minus 1, up to 270, etc. You can see that it's clearly been shifted up 1. So the d in this general form, or r in this question, will be 1. The phase shift, or p here, we need to think, how has that been shifted at all? So on the normal cosine graph, the peak is at 0, 1 here. That's where the peak is, or at 180. In this graph they've drawn, the peak is at 45, it looks like, 45 degrees. The minimum is at 225. It looks like they've shifted the graph along 45 degrees. So 0 to 45 is 45, or 180 to 225 is 45. So P will be 45 degrees. And that was part B for 2 marks, and question 22 for 3 marks. Question 23 says prove that 4x squared take 8x plus 7 is positive for all values of x. Right, so if a quadratic is positive for all values of x, that means it won't have any roots. It won't have any solutions where x equals 0. So in other words, this quadratic, if the x-axis was here, this quadratic would be completely above the x-axis. And usually proving that it's positive for all values of x means completing the square. So to start that off, I would factorize by 4. So this would equal 4x squared take 2x plus 7 on 4. And then try to complete the square on this factorized quadratic. So this would equal 4. And one way to do this is to just take half of the coefficient of x. And that becomes the second term in my squared brackets. So this will be x take 1 all squared. And then do a little note to yourself if you need to, expand that out. That would be x squared take 2x plus 1. But we have a plus 7 on 4. Another way of writing 7 on 4 is 1 3/4. So if I were to expand that out, I get 1. And I need to add on an extra 3/4 to make those two things equal. So add on 3/4 to this, and that makes those two expressions equivalent. Expand that 4 out again. So this would be 4 times x take 1 squared plus 3, right? 3/4 times 4 is just 3. And then we have it in a form where we can actually read off the minimum. So these two numbers here are actually the minimum of the quadratic, the 1 and the 3. So you could say the minimum is at 1, 3. Or you could also say that this part of the expression can never be less than 0, because whatever number you put in for x there, you always square it, so it's always going to be positive. So you could also say that 4 bracket x take 1 squared is always greater than 0 or equal to 0. So therefore the values are always positive for any value of x, or x belonging to the real numbers. Okay, so yeah, the main point there is to use completing the square. That was question 23 for 3 marks, and that was the end of the paper. I hope you found this useful. If you did, please leave a like, subscribe if you want to see more content, and I'll see you in the next one. Bye for now.